Hey guys, it's me Chiku from Chiku Study Corner, and today I'll be dealing with the chapter 7 of Chemistry, textbook 1, that is P block elements. That is chapter 7 of Chemistry class 12 CBSE. So I'm dividing this chapter and now we'll be dealing about the group 18 elements. So let's get started. So the P block is from group 13 elements. Okay, alright. Elements to what? Group 18 elements. Okay, so in this session, first I divided this chapter into each of these elements. So let's learn about group 18 elements first. So we learn about the group 18 elements in these upcoming two sessions. So over here we have to learn the terms given for these elements in that group. That is called as inert gases or rare gases, or it is called as zero group elements, or noble gases. Okay, so these are the terms given to these elements. So let's see which all are these elements. So the elements are, first one is, so the group 18 elements are, first one is helium, second one is neon, argon, krypton, xenon, radon and organoxide. So let's see about all of this. So before we discussing about the electronic configuration, the atomic size, we have lot of terms and points to learn. Before that, I'll tell you why these are called as inert gases, rare gases or zero group elements or noble gases. So let's see. From helium to xenon, what are they? They are found in the atmosphere. Okay. Whereas radon and organoxide, both of them, what are they? They are radioactive elements. Okay. So let's say, for example, these things or these radioactive elements are rarely found because they are very minute in the surroundings. And that too, next is about to talk about helium. Helium, where is the source of helium coming from? The source of helium is usually the natural gas. Okay, so the source is natural gas. And the most occurrent metal or the most occurrent element in this P block element or in the group 18 is argon. So that is the most occurrent. Okay, so this is the most occurrent is argon. So that is to talk about generally what is P block elements. And then one more thing that we have to mention over here is that these elements, okay, these elements have their, what you say, electronic configuration and atomic size. So to talk about helium, we know what is the atomic number, that is 2. Next one is neon, what is the atomic number? 10. Then argon, what is the atomic number? 18. Then what? Krypton, what's the atomic number? 36. Then we have xenon. What is the atomic number for xenon? That is 54. And then we have radon and organoxide. So what is radon? That is 86 and organoxide is 118. So these are the electronic configurations, or these are the atomic number of each of these elements. So now let's see why are these names called. First thing, noble gases or inert gases. I'll write it together. So they are called as normal gases or inert gases because of their reaction with the other elements. They are less reactive. We say inert gases are very less reactive. Because of their reactants only they are called as both noble gases or inert gases. By low reactants. Okay. And next one, rare gases. Why do you call it as rare gases? What's the meaning of the word rare? The meaning of the word rare is it's barely found, or it is very, it's not very common. So the same way rare gases are not common and are rarely found in the atmosphere. So because of what? Rare presence. And to talk about zero group elements, why do you call it as a zero group element? Do you know why is it? What is zero when you look at these things? What is zero? That is, this is a stable configuration. For a stable configuration, what is its valency? The valency of these compounds are 0. Is what? 0, and therefore it's called as zero group elements. Okay? So this is why these are called in particular names. And to talk about some of the properties, let's see what all are the properties that we have to learn. And by the way, all these inert or noble gases or zero group elements are gases. So what is that? All are gases. Note this point, it's important. And last thing is, we have to learn about the formation of compounds, or the formation of what all. We have only to learn about two of them, which are they. The first one that we have to learn is about radon, and the second one is about organocin. Okay? So, first let's discuss about radon and then move on to organocin. Because radon and organocin, what are they? They are radioactive elements and their formation is a bit important. So, let's learn. So, preparation. So, let's see. First one is radon. So, let's take radon. Take radium metal of what is its atomic number and what isotope do you choose? You will take it as 88 and 226. Radon 88, 226 will undergo dissociation and what would happen? They will form our compound Rn222. What is this? 86 plus what will they form? They will form helium-24. This is an isotope. Okay. So, what is happening over here? Here there is a decay of what? Decay of radium. Am I right? Decay of radium is happening. What is happening? Radium gets split and form into what? Radon and helium-24. Okay. So that is what is happening for the preparation of radon. So now let's see the preparation of organocin. So let's write. Organocin is Og and that is 118. Didn't we learn how do you name these compounds that come after 100? That is their atomic number is more than 100. How do you name it? We learned it last year. So let's see how do you name it. So this is what? This is actually now it is called as organocin. Before it was written as what is the representation of 1? That is U. And again what is this? U. And what is 8? 8 is represented as O. So UUO was this element's name. So now let's write the method of preparation. So first thing what we do is this organocin is prepared synthetically. What? Synthetically prepared. By what? It is synthetically prepared by collision of caliform CF and what? Calcium ion. Calcium ion. This is how it is obtained. So let's write the equation. Okay. So what is happening over here? And a special thing to be noted, the calcium ion used is a rare isotope. Okay. rare isotope. So let's write the equation. So the equation is calcium isotope, that is over here, that is 2048 plus CF. What is the number for that? 98 to 48 would give rise to what? Our organism. So we write organism 118. We learned number is 118. If you add it, we get 118. And what is the number above? That is 294. You add this and this, you will get 294. Okay? So that is how you obtain organism. So now let's see the general properties. So the first one that we have to learn is electronic configuration. So let's write it. General properties. First one is electronic configuration. We know that inert gases have stable electronic configuration. Am I right? And what is the general equation? So general equation is NS2NP6 or NP. Yeah, NP6 is that is what is our electronic configuration of inert or 18 group elements. Okay, so can you say any exception for this? What is the exceptions that come under this elements, that is helium, neon, argon, krypton, xenon, radon and arganis? Which is that? Which all does have lesser number or more number? What is that? Is there something which have only this as its electronic configuration? Yes, that is helium. So what is that? Helium is an exception when it comes to the general and electronic configuration only. So that is an exception. So that is to talk about electronic configuration. So next thing that we have to learn is ionization enthalpy. So let's see what is ionization enthalpy. So the first one was electronic configuration. Second one is ionization enthalpy. So what is this? That is the energy required to remove an electron from the outermost shell. Okay. So it is represented as delta IH. Okay, this is important. So ionization enthalpy is represented as delta IH. So let's see. For ionization enthalpy is the removal of an electron from the outermost shell. How easy would that be? According to the easiness, what happens? Ionization enthalpy decreases. As ionization enthalpy increases, what happens? The ease to remove that electron decreases. So I told you that what our elements are having stable configuration. Would you like to be in a state of like unstableness? If you are standing still, would you like to stand upside down on your head? No. If you are kept like that, you would come back. And if you are on the other way around, what would happen? Unstable way, if you are standing, you will come back to a normal position. But if you are in a normal position, would you like to go to an unbalanced state? No. The same way, what happens is these stable electrons also doesn't like to move to the unstable section, or they don't like to remove an electron, and therefore they have high ionization enthalpy. So let's write. So what happens is there is high ionization enthalpy. Am I right? So what happens? I told you when you take the group 18 elements, when it goes like this, when it goes down the group, what happens? Delta IH value decreases. Why does it decrease? Owing to its size. As size increases, what happens? The bond between the outermost atoms, or the outermost outermost atoms and the electrons and the the nucleus would have more distance. As the distance increases, the force of attraction would decrease, and hence it's easier to remove. And therefore, when that is easier to remove, what is there? There is a higher ionization enthalpy. So when it goes down, what happens? Lower ionization enthalpy when it's easy to move, because you don't have to give that much of energy. Because the definition is energy required to remove an electron from the outermost shell. If that is tightly bound, you need more energy. If it is loosely bound, you don't need much energy. You can just kick it out. Yeah. So as you move down the group, what happens? Delta IH value will decrease. So now let's see the third one. So the third property, that is what we are going to learn. So let's see what's the third property. The third property is also an enthalpy, that is electron gain enthalpy. So let's see what's electron gain enthalpy. Electron gain enthalpy. So what is electron gain enthalpy? What does the word gain means? To get or to achieve or to, hold on to yourself. To gain something is to win something or to get something. So let's see what is electron gain enthalpy. So let's see the definition first. So that is the amount of energy that is required, that is not required, that is released actually. Released for what? When what happens? An electron is accepted. So what is that? That is the energy that is required, or that is the energy released when an element accepts an electron. So I told you they have a stable configuration. Would they like to go to an unstable state? And that to this for this stable state, what is happening there? That is, the shells are completely filled and there is no space for another electron in the same shell. Because let's say if this is a nucleus, there is 2 and over here there is 8. And if they want another electron to come from somewhere, what would happen? They would have to move to another shell. They can't be accommodated over here. So they'll move to another shell. So to move to a higher energy level, what is required? The release of energy is required. And that is called as what? Electron gain enthalpy. So let's see how is the trend of this going over here. So I'm just rubbing the definition. I'll tell you the definition once more. That's the amount of energy that is released when you have to accept a pair of electrons or electrons to your element. So the electron gain enthalpy is represented as delta EGH. So, and the delta EGH value is positive. Why is it positive? Due to stable configuration, what happens? There is a decrease in the tendency to accept electrons. Am I right? So, if you have to add an electron, they won't accept. If you have to add an electron, what would happen? They would have to move to a higher energy level and hence there is energy released. Am I right? They won't allow any acceptance, but if there's a situation where they have to accept an electron, what would happen? They should have another shell for accommodation. And since they are making another shell, there is release of energy. And since release of energy is positive, delta EGH value is also positive. So that is our third property. And now let's see about atomic size or atomic radii. So let's see what is that. Atomic radius. When you move across the table, the periodic table, what happens usually? The size would decrease. Size decreases as moving across the periodic table. So, what is that? Now there's a change. If you're looking like this, what would happen? The halogens would have a bigger size than that of what our group 18 or our noble gas. And therefore, what is that? We always have a mindset that this would only decrease, but it is not like that. In the case of group 18 elements, so let me write group 18 elements, slightly larger radius than group 17. Why is that? There's a reason, there must be a reason. We have learned about different radiuses or different forces in our previous classes. So, over there we learned about something new, some van der Waals force. Am I right? What did we learn? Van der Waals force is the weakest force and hence it has a little more bigger radius than ionic radius. So what happens? And therefore, since it is a van der Waals force, the radius would be larger than that of the radius of what? Halogens. Okay? So that is to talk about atomic radius. So that is all to talk about the general properties. Okay, we finished the general properties. Now we have to learn about the compounds that are formed. So, before talking about the compounds that are formed, there are only compounds for a few of them in the 18th group. So, let's see. Which are the group 18 elements? We know that is helium, neon, argon, krypton, xenon, radon and organocin. Am I right? So, out of this, these two are not considered. Why is it not considered? Because they are not found in the atmosphere. And then, next one is to talk about, let me tell you two questions. Why does helium, neon and argon do not form true compounds of itself? And the other two questions are, or the other question is, why does krypton and xenon form its compounds? So, why is that? When owing to the size, what happens? There is a decrease in the enthalpy, and when there is a decrease in ionization enthalpy, what happens? Alright, what happens when there is a decrease? There is a removal of electron is easier, and therefore what happens? Reactions are also easier. When you can remove something, you can also accept something to place or to, make the configuration stable, and hence only krypton and xenon forms true compounds. So let's see the first one. First one is to talk about xenon. Xenon will form more compounds than krypton. Why? Because it has a lower ionization enthalpy than that of krypton. Yeah? So let's see. Compounds of xenon. So first compounds, it's a set of compounds that we have to learn, that is XeF2, XeF4, XeF6. We have to learn about other compounds also, that is XeOF and XeO2F2. And there's one more compound that we have to learn, XeO3. Okay, these are the compounds that we have to learn. So, first we learn about this. These are known as xenon fluorides. Okay, what are they? Xenon fluorides. Okay, so let's see how you prepare this. For preparation of xenon fluorides, you don't have to learn the reaction in particular, but you have to learn about the conditions. So, the conditions are important for these two. We won't be discussing about these. I'll let you know why we won't discuss about these, because we are learning the formation of these compounds later. Okay. So let's learn about these first. So the first one that we have to learn is XeF2. So let's write the formation of XeF2. It's obviously xenon plus fluoride giving XeF2. So let's write it. Xe plus F2 would give rise to, when this reaction should happen, what is the condition? That is Xe should be in excess and F2 would be in a given amount. So X is Xe plus F2 under some conditions. What is the condition? There is a temperature and pressure condition, that is 673 Kelvin and 1 bar pressure. If these conditions are just applied only, this will form XeF2. Okay? This is the formation of XeF2. I hope you might have understood. What is it? Xa should be in excess, that should be in 673 Kelvin and 1 bar pressure. So, now let's write the second compound, XeF4. XeF4, what is that? That is same, Xe plus F. How many F? There is, we write it as F2. How many F2 should we take? We need 4. So, we will put it 2 and make it 4. And we have some conditions. Before that, we will write XeF4 on the other side. XeF4 is formed. If to form this, what is the condition? The condition is, over here it should be 873 Kelvin. That is 200 Kelvin more than that of the previous one, XeF2. And what is the pressure? The pressure should be 7 bar pressure. And over the previous one, we took excess Xe. So now we are taking it in the ratio 1:5. That is, F2 is in excess. Okay? So that is XeF2. I mean XeF4 formation. So now let's see XeF6. Now for XeF6, what happens is, XeF6 is mentioned as Xe plus 3F2. So because we have 6, no? Would give rise to what? XeF6. And what is the condition? That is 100 less than that of XeF2 for temperature. That is 573 Kelvin and 60 to 70 bar pressure. And what is the ratio? 1:20 ratio. Xe should be in lower amount than that of F2. That is 1:20 ratio. That's how compounds of xenon are formed. So friends, that's all for today's lecture. I hope you might have understood it and liked it. If you have understood it and liked it, please give my video a huge thumbs up and also subscribe to my channel if you are new to it. And share my videos with your other